Hey guys, Pogo here, and welcome to the next episode of Intro to Swift. In this episode, we're going to look at the different object types in Swift. These are those kinds of structures that you define like classes. There are 4 that we're going to talk about in Swift, and I believe these are all of them, at least they're the main ones. Those are classes, enums or enumerators, structs, and protocols. So we're going to go through each one individually, look at an example for each one, and then compare and contrast and see where each one would be useful. So let's go ahead and get started. We'll go ahead and start with the best example, which is a class. The class exists in pretty much any object-oriented programming language, and it allows you to store variables, instance variables, or fields. You can have different initializers or constructors, or you can also have functions. So that is the main thing that you would use for an object-oriented design. So we're going to write a class called person, and this class is going to represent a person. And there are 3 parts to a class. Not all of them are required. The variables, the initializers, and the functions. So we can create a variable called name, which we'll set to be a string. So we can have the name of the person, and let's just go ahead and stick in their age for fun, and that'll be an int. Next, we have our initializer, where it takes this in, and I believe that I had gone over that before, but in Swift, to initialize something, you use the reserved word init. It's kind of like using the word person or the class name in Java. Use the word init, and then you specify all of the parameters that you need. So name, which is a string, and age, which is an int. Sorry about that. So let's go ahead and assign these. Use the self keyword to access these things up here. So self.name is equal to name. That sets this name up here equal to whatever this name is here. And then, of course, self.age equals age. So that is our initializer. Takes the name and the age and assigns them appropriately. And then finally, we could, write some functions if we wanted to. Functions aren't as frequently used in Swift because you don't write getters and setters. You just access these things directly. But for example, we'll write a useless function. We'll write we'll just write a function called getDescription, and this would better be represented as a variable up here, honestly, but it would just return, name is age years old. And obviously this isn't terribly useful, this getDescription, but I just want to demonstrate that you can use functions. So we will declare a person, so we'll call it var p equals person, and then I have my initializer that I made here that requires a name and an age. So the name will be Pogo, age will be 16, and then you can see it'll tell me that it has a name of Pogo and an age of 16, so those variables were assigned, and if I wanted to, I could call p.getDescription, and it would print out Pogo 16 years old. It just takes, name Pogo and age 16 and puts them in this little sentence here. So that's a quick demonstration of classes. That shouldn't be anything new to anyone who's worked with other object-oriented languages. It operates very similarly to regular classes. There are a couple of cool things that we haven't looked at yet, but mainly it's just a class. Let's now take a look at structs. Why not? A struct exists in some languages, not in Java, but it does exist in many languages, so you may be familiar with it. A struct is very similar to a class, but it's designed to be a very simplified version of a class. If you only want to store pieces of data, if you want to have a couple pieces of data and you want to store them easily with a small amount of boilerplate code, and all that stuff, you'll see why a struct is nice. But we'll go ahead and create a struct, and we'll call this one item. And this will be in charge of, I don't know, keeping track of an item inventory. So it'll have which item we have, and it'll have which, what the quantity is, how much of it we have. So we'll say var item is a string, and var, not age, I'm sorry, var quantity is an int. Not that. Okay, so the struct is like that, and I believe that you don't want to put any initializers in here because it will automatically do it. You can put your own initializers in, but you don't need to. And you can also put functions in, but the reason why you could use this is we'll go ahead and say item, and you'll see that an initializer is automatically created for you. So you don't have to define your own if you don't want to. And then you can easily fill in all of the data. So the item is bananas, and the quantity is 12. So there are 12 bananas. And there's not a whole lot to do with it. I can do item and quantity. I can get access to those. I believe I could also write functions in there if I wanted to. But a struct is essentially just a simplified class. It's good for something like this, where you just want to have these two variables, and that's it. And it'll create this nice initializer for you there, and then you're good to go. So that is a struct. Now we'll take a look at enumerators. An enumerator exists as well in many other languages, so you're probably familiar with it. An enumerator contains a set of values, a static set of values, as in they don't change. So this is good when you have a list of things that is never going to change, and then with that you get the ability to easily access them. So for this example, we'll go ahead and create an enumerator that represents operating systems, and it'll contain, Mac OS, Windows, and Linux, let's say. Those values aren't going to change. Those are the 3 operating systems, and whatever. And you can use this for other things. If you're making a game, you could have an enumerator of the different enemy types. You could have, your player and then all the different types of enemies in the enumerator. There are plenty of places that you could use it, but instead of using, constant integers or strings, you can use enumerators. So we'll go ahead and make one called operating system. And perhaps this isn't the best example, but I think it illustrates the idea well. So for each constant in the operating system, or in the enumerator, you write the word case, and then you write the value. And in Swift, you write your values starting with a capital letter, but not in all caps. In Java, you write it in all caps with underscores, or that's the convention, but here you don't. So in this case, for the operating system, we'll make a one called Mac OS, Windows, and Linux. Those are the 3 that we'll stick in there. So we have our 3 different cases, and I believe you can just comma delimit them if you want to, but I don't, because one of the cool things about enumerators is that you can assign values to them. So in Java, you can create initializers and use them like that. You can, have initializers, and I could give Mac OS, Windows, and Linux some initial values, and that would be fine. In this case, Swift is a little bit different. To specify what you want to use, you write a colon, and then what type of value you want them to have. So in this case, we'll say double, and this is going to keep track of the version number. So what this means is that I can now assign Mac OS, Windows, and Linux double values, and then I can retrieve them later. So we'll say Mac OS, the latest version is 10.10 Yosemite, which is what I'm using. In the case of Windows, I'll go ahead and say Windows 10, which is coming out soon. In the case of Linux, I don't know. I mean, if you're talking about the Linux kernel, I'm not going to embarrass myself by taking a guess, but there are tons of different versions of Linux, so I don't know. Let's just make that -1. Okay, so if we want to use these enumerators, there are a couple of ways of doing it. We can first refer to them directly. We could say var, O is equal to operating system dot Mac OS, Linux, or Windows. And I can also access this raw value, which tells me what type of raw value it is. So in this case, it tells me that it's a double. So if I wanted to know that they all store doubles, I could. In this case, we'll say that we want to go with Mac OS, and now this O contains a reference to Mac OS, which is a constant. It's an enumerator value. And I can then do the hash value and the raw value. Raw value, you'll see, is a double, and that's going to be whatever this value is right here. So I could go ahead and say, I could print out O.raw value, and you'll see that it prints 10.10, or 10.1, I guess the 0 kind of goes away. Maybe it should be a string, but let's make it a string. So we'll change it to be a string, and we will say 10.10 Yosemite, and then this is Windows 10, and then Linux unknown. I guess that makes more sense. So now you'll see it'll say 10.10 Yosemite. The raw value is a string. It grabs that raw value and then tells me that it is 10.10 Yosemite. And then there's also the hash value, which will tell you the order. So macOS is 0, Windows would be 1, and Linux would be 2. So what that says is, if I look at macOS and it has a hash value of 0, that means it is the 0th value. So I can easily tell the order. I can tell that macOS is first, Windows is second, Linux is third with that hash value. So those are both useful. Finally, before we move on to the last thing, you can also do pretty cool. You can almost instantiate operating system, which looks a little bit weird, but you can pass in a raw value and have it return. That's an optional, so it'll either give you back a an operating system or nothing. So if I put in the raw value of unknown, O would then, O would then be some sort of numerator value, and we can just unwrap it actually. And if I do O dot that, the raw value is unknown because it knows that it is Linux. If I type in, say, 10, the raw value would be 10. So you can get it based on the raw value. So in this case, it wouldn't really make sense, but you can retrieve a raw value from a constant. You can also retrieve a constant from a raw value. And if I put in a number that doesn't exist, then it's going to give me an error because this operating system would be null or nil, and then I've just tried to unwrap a nil thing, so that wouldn't work. We'll just change this back to be operating system.macOS. And also a cool thing is that if you know exactly what you're referring to, you can just use dot notation like that. So if I specify that this is an operating system, I don't have to write the word operating system again. I can just use the dot. If I don't have that there, it's not going to work because it doesn't know what type O is. But if I say specifically that it's an operating system, or if I know that it's an operating system, maybe it's a function parameter, then you can just use the dot, and you don't have to write the word operating system. So that's a nice little notation. Finally, we're going to take a look at the last object type in Swift. It is called a protocol, and it's essentially a more powerful interface. In most languages, like Java, an interface allows you to define function or method headers, the methods that need to be implemented by anything that implements the interface. You can't implement any of the methods. In Java 8, there are default methods, which are half-implemented sort of methods, and you can't have any variables except for constants. In Swift, that's all been figured out, and it's actually really nice. So let's take a look at a protocol, and we're going to create a protocol called named. And the protocol called named means anything that has a name it's called conform to the protocol. And I'm going to say that in order for something to be considered named, it needs to have a variable called name, which is a string, and I'm going to write the word get. So that means that in order for something to be named, it needs to have a variable called name, needs to be a string, and it needs to be able to be gotten. So in the case of something like item and quantity, those are automatically able to be get and set. But if you're talking about the properties that are computed like we looked at in a past video, you can't use something that can only be set here. So this is saying that it needs a variable called name, which is a string that can be gotten in order to be considered named. And we'll do one more thing. We're going to require that anything that can be named has a function called rename, which takes in a new string. And this might not make a ton of sense, but perhaps rather than just changing the name directly, it wouldn't be a bad idea to have a rename function, because let's say that you're working with a database. If someone wants to change the name of something, and obviously this could be accomplished with a property, but if someone wants to change the name of something, perhaps you want to deal with the old name or the new name before you do something. So the protocol name just states what criteria something needs to meet in order to be considered named. And I can go ahead and write a function outside of that, a function called print named. I can refer to named as a type. And I can print out n dot, and I have access to name and rename because I said that those are what I need. So if I call this print name, I can give it print named. I can give it anything that is considered named, anything that conforms to this protocol, and it'll print out its name. So in really all three of these cases, you can use the named protocol. I'm only going to use it in two. I'm going to ignore operating system because that doesn't make a ton of sense. But for person, I use a colon, and after the colon, I can write any protocols or superclasses that person has. So I'm going to say that this is the named protocol, and it's going to give me an error because, well, named needs var name string, which is there, but it also needs a function called rename. So we'll write the func rename name string. And all I'm just going to do is say self.name equals name, and perhaps I'll even print out, we'll say renaming self.name to name. So whatever the current name is, renaming to the new name. And close that. So it'll print out that message before setting. And then also for item, it's a structure. I can say that the item is named. I'm going to rename that to name instead of item, and then here I can write the func named, and in this case I'm going to just say do nothing because I don't want to be able to rename an item. Let's just say that. Use of named. Alright, so let's just stick named up at the top. So I guess it wants it to be up at the top. Okay. Good, so named is up at the top, and I'll stick that print named thing up there as well. And there we go. So now person and item, oh, sorry, doesn't protocol, oh, I'm sorry, that should be rename. So the person class and the item struct are both called named. And this isn't anything that's terribly new per se, but it is something cool. It's good to know that protocols interfaces are called protocols in Swift. And then finally, I could just call the print named function with something that's named. So I could do it with a person named Pogo at age 16, and I could also print named with an item that is named apples with a quantity of 10, or probably just apple. And you'll see that I go up here 2 times. Let's see the 2 times. Hang on. Pogo and apple. So it's a little bit ugly, but you'll see that I called it with the name of Pogo. And in that case, it found the name being Pogo. And then there with the apple, it found that the name is Apple. So it is able to work like that. Alright, I think that is all for this video. So those are the 4 main object types: protocols, which are like interfaces; classes; structures, which are like simplified classes; and enumerators, which contain a bunch of constants that are determined at compile time, or written right out in the code, and those make for easy access. So as always, subscribe if you want to see more, comment with what you want to learn. If you like this video, click the like button, and I'll see you guys soon with some more coding. Bye for now.